The Pacific Ocean covers more surface area than all of the planet's continental landmasses combined. Its 165 million square kilometers contain approximately half of Earth's oceanic water, and in certain places descend to depths exceeding 11 kilometers. From the first Polynesian navigators to modern satellites, this ocean has been studied, mapped, and crossed millions of times. Yet it still holds secrets that challenge scientific understanding. 21st century submarine technology, with its autonomous exploration vehicles, multi-beam sonars, and high-pressure cameras, has made it possible to access regions that were once absolutely inaccessible. What has been found there does not always fit established models. Shipwrecks that appear where no map records them, sounds that travel thousands of kilometers with no known origin, creatures of impossible dimensions, oceanic patches that cover territories larger than continents, and geological structures that suggest the existence of lands submerged millennia ago. Each layer of the Pacific, from the shallow photic zone to the deepest hadal trenches, contains phenomena that deserve attention. Some have already received partial scientific explanation. Others remain unresolved, debated in laboratories and specialized journals without any consensus. And many others continue on the boundary between the verifiable and the speculative, awaiting the instruments or expeditions that may one day resolve them. It is significant that, despite being the most explored ocean in terms of navigation routes, the Pacific is also the one with the largest expanses of seafloor still unmapped with precision. High-resolution bathymetry covers barely 20% of its seabed, which means that the topography of 4/5 of the Pacific floor is known in less detail than the surface of Mars or the Moon. Every new bathymetric expedition finds mountain ranges, volcanoes, and canyons that appeared on no chart. The Pacific currents, from the Kuroshio Current in the north to the Humboldt Current in the east and the network of equatorial countercurrents, form one of the most complex water and heat transport systems on the planet. These currents are not simple surface water flows, but three-dimensional structures that extend from the surface to thousands of meters in depth, transporting heat, nutrients, organisms, and pollutants between regions separated by tens of thousands of kilometers. The Humboldt Current, for example, which rises from the depths off the coasts of Chile and Peru carrying cold, nutrient-rich waters, supports one of the most productive fisheries on the planet and regulates the climate of the entire southern cone of South America. When El Niño weakens that current, its consequences are felt from the Atacama deserts to the tropical forests of Indonesia. The Mariana Trench extends east of the islands of the same name in the western Pacific Ocean, tracing an arc approximately 2,550 kilometers long with an average width of 69 kilometers. It is the result of the subduction of the Pacific Plate beneath the Mariana Plate, a process that has been active for tens of millions of years and has sculpted the deepest known point on Earth's surface, the Challenger Deep. The most precise measurements made with multi-beam sonar and by the crewed descent vehicle limiting factor in 2019 place the maximum depth of Challenger Deep at 10,935 meters, although different campaigns have yielded slightly different values depending on the methodology used. To put that figure in context, if Mount Everest were placed on the floor of the trench, its summit would remain more than 2 kilometers below the surface of the ocean. Conditions at the bottom of the trench are extreme in every sense. Pressure reaches approximately 1,086 atmospheres, which is equivalent to about 1,100 kilograms per square centimeter. The temperature ranges between 1 and 4 degrees Celsius. The darkness is total, absolute, without a trace of sunlight. And yet, even there, life persists. The Mariana Trench is not the Pacific's only abyss. The Tonga Trench in the South Pacific reaches 10,882 meters at its deepest point, horizon deep. The Kermadec Trench, northeast of New Zealand, exceeds 10,000 meters. Each of these trenches corresponds to an active subduction zone, and each harbors its own hadal ecosystems with differentiated biological communities that reflect millions of years of evolution in isolation. Expeditions to Challenger Deep have documented unexpected biodiversity. In 1960, Jacques Piccard and Don Walsh descended aboard the bathyscaphe Trieste on the first human journey to the bottom of the trench and observed, to their surprise, a flatfish on the sea floor, demonstrating that vertebrates could survive under pressures considered incompatible with complex life. Decades later, that observation has been widely confirmed and surpassed. Sediment samples collected in the trench contain communities of foraminifera, amphipod crustaceans, polychaete worms, and sea cucumbers that have adapted in extraordinary ways to extreme pressure. Their cell membranes incorporate special lipids that prevent pressure from rupturing them. Their enzymes function under pressures that would denature the proteins of any surface organism. Some of these amphipods, such as Hirondalia gigas, have developed unique biochemical tools to break down the cellulose of plant remains that fall from the surface. In 2012, filmmaker and explorer James Cameron made the first solo descent to Challenger deep aboard the submersible deep-sea Challenger, collecting biological and geological samples during several hours on the bottom. Among the findings of that expedition were microorganisms previously unknown to science and sediments that revealed the accumulation of organic material originating from across the entire Pacific Basin over millions of years. An especially relevant discovery in the Pacific Hadal Zone was the identification in 2014 of the snailfish Pseudoliparis swiri at a depth of 8,145 meters in the Mariana Trench. This translucent fish, with the appearance of a giant eel and an almost gelatinous musculature, became the deepest vertebrate ever recorded. Its body accumulates trimethylamine N oxide, an organic compound that stabilizes proteins under extreme pressure and that is present in increasing quantities at greater depths, functioning as a sort of molecular antifreeze adapted to the conditions of the abyss. A discovery that has generated significant scientific concern is the presence of industrial pollutants in organisms collected from the bottom of the trench. A study published in 2019 Inches, the journal Nature detected polychlorinated biphenyls, PCBs, and other persistent organic compounds in the tissues of amphipods, captured at nearly 11,000 meters deep. These substances, whose production was banned in most countries beginning in the 1970s, reach the ocean floor attached to plastic or sediment particles that slowly sink from the surface. The irony is that the most remote and inaccessible place on the planet has not escaped contamination generated on land. The concentrations detected were comparable to those of the most polluted industrial estuaries in the world, revealing the extent to which oceanic systems transport substances from populated coasts to the farthest corners of the abyss. One of the most disturbing properties of the ocean depths is their tendency to produce large versions of organisms that in surface waters are small or medium-sized. The phenomenon, known as abyssal gigantism, has been documented in dozens of taxonomic groups and remains the subject of debate regarding its causal mechanisms. The giant squid, Architeuthis dux, is perhaps the best-known example. With lengths that can exceed 13 meters, including the tentacles, and eyes reaching 30 centimeters in diameter, these cephalopods inhabit the mesopelagic and bathypelagic zones of the Pacific and other oceans. For centuries they were considered legendary creatures, the kraken of Norse mythology. Only in 2004 did Japanese researchers Tsunemi Kubodera and Kyoichi Mori manage to photograph a live specimen for the first time in its natural habitat at 900 meters depth in the waters of the North Pacific. But the giant squid is not the largest of its kind. The colossal squid, Mesonicoteuthis hamiltoni, reaches body masses exceeding 500 kilograms and lengths that could surpass 14 meters. Unlike Architeuthis, whose accidental capture by trawl nets is relatively frequent, the colossal squid is rarely observed, and much of what is known about it comes from the analysis of sperm whale stomach contents. The giant isopod, Bathynomus giganteus, is another paradigmatic example. Surface water isopods usually measure less than 2 centimeters. Their abyssal equivalent reaches 76 centimeters and can exceed 1 kilogram in weight. These arthropods, which resemble oversized pill bugs, inhabit seafloors between 170 and 2,500 meters deep in the Atlantic and Pacific, feeding on organic material that falls from upper layers. The goblin shark, Mitsucarina austoni, completes a gallery of abyssal creatures that seem designed to provoke perplexity. With its characteristic rostral projection, which can exceed 30% of the length of its head, and its protrusible jaws that shoot forward in a fraction of a second to capture prey, this shark of up to 4 meters inhabits depths between 100 and 1,300 meters in the Pacific. Live specimens accidentally captured have not survived more than a few days in aquariums, which makes their study enormously difficult. Most of the knowledge about its biology comes from dead specimens collected in trawl nets. On the speculative plane, although with some paleontological support, the megalodon, Otodus megalodon, represents the maximum known limit of gigantism in sharks. This predator, extinct approximately 3.6 million years ago according to the dominant scientific consensus, reached estimated lengths of between 15 and 20 meters and had teeth up to 17 centimeters long. Fossilized megalodon teeth are relatively common in coastal deposits around the world, including Pacific seabeds, and have been recovered in well-dated sediments. Periodically, claims appear about megalodon teeth collected from abyssal Pacific floors with datings of only tens of thousands of years, which would suggest a more recent extinction or even residual survival. Studies of manganese accumulation rates in those teeth, carried out mainly by oceanographer Clifford Pora in the 1970s, produced results that some interpreted as indicating an age much younger than that established by paleontology. Later reviews of those datings have been contradictory, and the debate over their methodological validity remains open. Although the majority scientific community does not consider the survival of megalodon in the deep Pacific plausible, the hypotheses regarding the mechanisms of abyssal gigantism are several and not mutually exclusive. The scarcity of food on the ocean floor would favor organisms with slow, long-lived metabolisms that accumulate mass over decades. Cold temperature slows metabolism and allows continuous growth in species that do not have a genetically fixed size limit. Extreme pressure could select for more robust body structures, and the absence of specific predators at certain depths would eliminate the evolutionary pressure that keeps organisms small in more crowded ecosystems. In 2023, an expedition to the southern Indian Ocean, in waters bordering the subantarctic Pacific, captured images of a juvenile colossal squid specimen and various species of deep-sea fish of sizes notably greater than previous records. Preliminary analyses suggest that certain zones of oceanic convergence, where cold, nutrient-rich currents meet warmer waters, function as incubators for these large life forms. To understand the Pacific's anomalous sounds, it is first necessary to understand the acoustic architecture of the ocean. At depths between 600 and 1,200 meters in Pacific waters, there is a layer where the speed of sound reaches an absolute minimum, determined by the balance between temperature, which reduces it, and pressure, which increases it. This layer acts as a waveguide channel that traps acoustic signals and carries them across distances of thousands of kilometers with minimal energy loss. It is called the SOFAR channel, an acronym for sound fixing and ranging, and it was discovered during the Second World War for military purposes. The SOSUS system, Sound Surveillance System, was designed precisely to exploit the properties of the SOFAR channel for Soviet submarine detection. Deployed by the United States Navy, beginning in the 1950s, it consisted of a network of hydrophones anchored at strategic depths on the floors of the Atlantic and Pacific Oceans. With the end of the Cold War, part of this network was declassified and transferred to the scientific community, which began to use it to record natural phenomena, earthquakes, underwater volcanic eruptions, glacial ice movements, and the biological sounds of cetaceans. It was in that context that signals began to appear for which there was no immediate answer. In the summer of 1997, the hydrophones of the SOSUS system captured an acoustic signal of extraordinary power in the South Pacific. The sound, informally named the bloop by the analysts who studied it, was clearly detectable at more than 5,000 kilometers distance from its approximate point of origin, located around the coordinates 50 degrees south, 100 degrees west. The spectral characteristics of the bloop initially placed it in a category difficult to classify. It had a fundamental frequency of around 1 Hz, rose over approximately 1 minute, and its amplitude was greater than that of any biological sound previously recorded. NOAA analysts pointed out that the profile of the sound resembled sounds produced by animals, which generated decades of speculation about the possible existence of a marine creature of unknown size in the depths of the South Pacific. The scientific explanation arrived years later, although without the dramatism of the zoological theories. Research published from 2012 onward established that the bloop was consistent with the signals produced by the breaking and collapse of large masses of glacial ice, specifically icebergs or the Antarctic ice shelf. This type of event generates low-frequency acoustic signals capable of traveling thousands of kilometers through the SOFAR channel. The fact that the approximate point of origin coincided with the quadrant of the South Pacific closest to Antarctica reinforced this interpretation. Less resolved than the bloop is the sound known as upsweep, also captured by NOAA's hydroacoustic systems since 1,991 inches, a continuous and periodic manner. Unlike the bloop, which was a singular event, the upsweep repeats regularly, especially in spring and autumn, with an intensity that has varied over the years, but has never disappeared since its detection. The signal consists of series of short-duration ascending sweeps that are grouped into sets and repeated with irregular periodicity. Its origin has been approximately located in the central South Pacific, near the Pacific Ridge. Some researchers have proposed that it could be associated with submarine volcanic activity, specifically gas emissions, and the movement of hydrothermal fluids in the environment of oceanic ridges. However, this hypothesis has not been conclusively confirmed, and the exact source of the upsweep remains unidentified. What makes the upsweep particularly notable from a scientific point of view is its constancy. More than 30 years of uninterrupted recording of a signal whose source has not been located or characterized represent a remarkable anomaly in a field that has extraordinarily sophisticated analytical tools. The global network of hydrophones can determine the position of an underwater acoustic event with a precision of tens of kilometers, but the upsweep has resisted such triangulation. The catalogue of anomalous sounds of the Pacific is not limited to the bloop and the upsweep. NOAA maintains a record of signals given names as evocative as slowdown, train, whistle, or Julia. Slowdown, recorded in 1997, is a descending frequency signal lasting several minutes, whose origin has also been attributed to movements of glacial ice. The sound known as train, also captured in 1997, produces a low-frequency noise with a certain rhythmic regularity that resembles that of a moving train, and its probable origin is located in areas of submarine seismic activity. Julia, recorded in 1999, was an extraordinarily long sound, approximately 15 seconds in duration, captured by hydrophones on both sides of the Pacific simultaneously. Its intensity was sufficient to be detected across the entire network. The most accepted hypothesis relates it to the detachment or grounding of an Antarctic iceberg against the shallow ocean floor. Whistle, recorded in 2002, is perhaps the most enigmatic of all, since its spectral profile does not clearly correspond to any known geological process or any identified marine organism. Research on the subject is more limited and its conclusions more tentative. NOAA itself maintains the categorization of whistle as a signal of unknown origin in its official records, without having issued a definitive interpretation. In the autumn of 2013, oceanographers monitoring the surface temperature of the North Pacific detected a thermal anomaly of unusual proportions. A mass of water, approximately 3 degrees warmer than the seasonal average temperature, had formed off the coasts of northwestern North America and was beginning to expand. By the summer of 2014, this mass of warm water, named by oceanographer Nick Bond as the Blob, covered an area approximately 1,600 kilometers in length. The biological consequences of the blob were devastating for numerous species. The absence of coastal upwelling, which normally brings cold, nutrient-rich water to the surface, impoverished the marine ecosystems of the North Pacific. Zooplankton populations collapsed, dragging down forage fish such as anchovy and sardine. Brown pelicans, seabirds, and marine mammals suffered massive episodes of starvation. Record strandings of sea lions, mostly undernourished pups, were documented along the coasts of California. Toxic algal blooms, favored by the warm water, closed fisheries, and contaminated shellfish along the entire western coast of North America. The blob also introduced into the waters of the North Pacific species from tropical latitudes that had never been recorded so far north. Leatherback turtles, sailfish, and barracudas appeared in waters that normally would have been lethal for them. The ecological inversion was such that some scientists began to speak of a new baseline state for the North Pacific ecosystem. The blob partially dissipated between 2015 and 2016, but a second similar event occurred between 2019 and 2020. Among its most serious consequences was the massive mortality of Pacific salmon, which returned to their spawning rivers in a state of severe starvation after failing to find the expected concentrations of prey in the ocean. Records of king salmon catches in Alaska for 2021 and 2022 were the lowest in decades, with direct economic effects on fishing communities along the North Pacific coast. In the mid-1990s, oceanographer and sailor Charles Moore crossed the North Pacific along an unusual route that took him through the center of the northern subtropical gyre. What he found there was not on any nautical chart, an extraordinary concentration of plastic debris extending in all directions as far as the eye could see. What Moore documented was the core of what is now known as the Great Pacific Garbage Patch, an accumulation of plastic waste maintained in position by the convergence of the currents of the North Pacific subtropical gyre. Current estimates place its extent at approximately 1.6 million square kilometers, although this figure is debated due to the diffuse and heterogeneous nature of the accumulation. The term patch or plastic island is misleading. It is not a solid surface or an area with defined boundaries, but rather a zone where the concentration of microplastics and plastic objects is several times higher than the oceanic average. Much of the material is composed of fragments smaller than 5 millimeters, the so-called microplastics, resulting from the fragmentation of larger objects by ultraviolet radiation and wave action. The biological consequences are profound. Plastics are ingested by fish, turtles, seabirds, and mammals that mistake them for prey or ingest them accidentally while filtering water. Recent studies have identified a community of organisms, informally called the plastisphere, that colonizes the surface of floating plastics and constitutes a radically new ecosystem in the open Pacific. This plastisphere includes bacteria, fungi, algae, and in some cases also crustaceans and marine insects that use plastics as a floating substrate to colonize the open ocean, an ecological niche that practically did not exist before the 20th century. There is also an equivalent patch in the South Pacific, discovered in 2011, which, although less studied, presents similar dimensions and characteristics. A study published in 2020 inches, the journal Science, found concentrations of microplastics within that southern patch in water layers at 200 meters depth, demonstrating that plastic pollution does not remain at the surface but penetrates the water column, affecting pelagic ecosystems throughout their vertical extent. Truk Lagoon, now officially known as Chuk Lagoon, in the Federated States of Micronesia, contains the largest cemetery of warships in the world. Beneath its calm waters rest the remains of more than 60 vessels of the Imperial Japanese Navy, along with dozens of aircraft and incalculable quantities of war material as a direct result of Operation Hailstone, carried out by the United States Navy between February 17 and 18, 1944. Truk was the most important naval base of the Japanese Empire in the Central Pacific, nicknamed the Gibraltar of the Pacific by Allied strategists. The two-day operation destroyed most of the fleet stationed there. Japanese casualties exceeded 4,000 dead, many of them sailors who were trapped in their vessels as they sank. Today, those hulls are artificial reefs covered in coral and inhabited by spectacular biodiversity. The Fujikawa Maru, 132 meters in length, has its holds filled with disassembled Zero aircraft that were waiting to be assembled when the American attack surprised them. The Nippo Maru preserves on its decks light tanks, anti-aircraft guns, and ammunition of all calibers. The most disturbing aspect for divers who visit the site is the presence of human remains in several of the wrecks. Japanese and Micronesian authorities have sealed some engine rooms and cabins out of respect for the dead. A growing problem in Truk Lagoon is the deterioration of the hulls and the risk of fuel leaks. The ships sunk in 1944 still retain in their tanks thousands of tons of oil that time and corrosion are bringing closer to the point of release. A spill of that magnitude would destroy the coral reefs that have grown over the hulls in 80 years and would contaminate the waters on which local communities depend. Estimates by marine engineers who have studied the problem indicate that the tanks of several of the vessels could begin to fail at any time, starting in the next decade. The heavy cruiser USS Indianapolis completed a top-secret mission in July 1945, transporting the components of the atomic bomb Little Boy from San Francisco to the island of Tinian in the Marianas, where it would be assembled before being dropped on Hiroshima. The delivery was carried out on July 26. 4 days later, on the 30th of July 1945, the Indianapolis was torpedoed by the Japanese submarine I-58 inches, the Philippine Sea, in the Western Pacific. The ship sank in 12 minutes, without time to send complete distress messages. Of the 1,196 men on board, approximately 900 made it into the water. What happened over the next 4 days constituted the greatest naval disaster in the history of the United States Navy. Without enough life jackets, without drinking water, at the mercy of the tropical sun during the day and nighttime temperatures that caused hypothermia, the survivors faced continuous attacks from oceanic and white-tip sharks that had gathered, attracted by the dead and the wounded. When a reconnaissance aircraft spotted the survivors by chance on August 2, only 316 men remained alive. The Indianapolis had not been reported missing for 4 full days because a bureaucratic error had led to its absence not being recorded as anomalous. Captain Charles McVeigh III was court-martialed, the only American commander tried for losing his ship in combat during World War II, in a decision widely considered unjust by the naval community. In 1968, McVeigh committed suicide. The United States Congress exonerated his memory in the year 2000. The remains of the Indianapolis remained undiscovered for 72 years. In August 2017, an expedition funded by Microsoft co-founder Paul Allen found the hull at 5,500 meters depth on the floor of the Philippine Sea. Analysis of the wreck confirmed the survivors' accounts regarding the speed of the sinking and the direction of the attack. The wreck site was designated a military historic monument by the United States government, and direct exploration is prohibited. In various regions of the Western Pacific, especially near the Solomon Islands, Vanuatu, and the volcanic chains of Micronesia, phenomena have been recorded that describe the temporary reappearance of sunken objects. These events have a coherent explanation in submarine volcanic and seismic activity. When an underwater volcano erupts, or when an earthquake of significant magnitude occurs on the ocean floor, gases trapped in the sediments are released in large quantities. This phenomenon, known as seafloor degassing, temporarily reduces the density of the water in the column above the geological event, which can cause sunken objects, including ship hulls, to rise toward the surface abruptly and apparently inexplicably to observers. The most documented case in the Pacific corresponds to the Solomon Islands region, where in the years following World War II, several fishermen and sailors reported sightings of metallic structures briefly emerging from the sea in areas where sinkings had occurred during the conflict. Subsequent analyses of seismic activity on those dates confirmed the correlation with medium-magnitude seismic events on the adjacent ocean floor. In 2002, in waters near Savo Island, in the Solomons, a submarine volcanic eruption temporarily raised the seabed several meters over an area of several square kilometers, bringing to light remains of Japanese and American vessels that had remained in sediments since 1942. The phenomenon was documented by local fishermen and later investigated by geologists from the University of Papua New Guinea. The SS Beichimo was a steam cargo ship built in Sweden in 1914 and put into service by the Hudson's Bay Company for the fur trade in the Canadian Arctic. In October 1931, the ship became trapped in ice near Point Barrow, Alaska, during a storm. The crew was evacuated, and, while waiting in a camp on land, the ship unexpectedly freed itself from the ice and began to drift. When they returned, the Beichimo had disappeared. Over the following 41 years, the SS Beichimo was sighted on repeated occasions in the waters of the Arctic and the North Pacific. Fishermen, hunters, and sailors reported encounters with the abandoned ship in 1933, 1934, 1939, 1962, and for the last time in 1969. On each occasion, the ship appeared in surprisingly good condition for the time it had been adrift, without crew and without moving under its own propulsion, simply following currents and winds. Some boarding attempts were successful, but none resulted in the recovery of the ship due to the difficulties of the Arctic weather. It is unknown when it finally sank. Canadian authorities launched a formal search campaign in 2006 without result. The Beichimo remains technically an unlocated shipwreck. A more recent and well-documented case is that of the Russian cruise ship MV Lyubov Orlova, built in 1976. The ship was seized in the port of St. John's, Canada, in 2010 due to unpaid debts. In January 2013, while being towed for scrapping, the tow cable broke and the ship was left adrift in the North Atlantic. Canadian authorities lost track of it a few days later. The Lyubov Orlova was never recovered. In February 2013, an emergency beacon signal was detected in the North Atlantic, consistent with what the ship would have emitted if it were sinking, but the signal could not be verified due to the distance. Officially, the fate of the cruise ship remains unknown. The tsunami generated by the Indian Ocean earthquake of December 2004, with a magnitude of 9.1, and the one caused by the Tohoku earthquake in Japan in March 2011 of magnitude 9, produced an oceanic phenomenon directly related to the Pacific, the generation of fields of floating debris that drifted for years across the ocean. The 2011 tsunami dragged approximately 5 million tons of material into the sea from the Japanese coasts. A 2017 study in the journal Science estimated that between 3 and 5% of that material reached the North American Pacific coasts between 2012 and 2016. Among the identified objects were fishing boats, floating huts, motorcycles, appliances and buoys with living Japanese marine organisms attached to their surface, including oysters, barnacles and fish, which traveled more than 7,000 kilometers across the North Pacific. This phenomenon allowed biologists to document for the first time that coastal organisms can survive trans-Pacific ocean crossings, which reconsidered some hypotheses about the biogeographical dispersal of marine species. The debris field from the Tohoku tsunami also provided crucial data on the drift dynamics of the North Pacific. Computational models of ocean circulation, calibrated with satellite tracking of floating objects identified between 2011 and 2016, showed that the North Pacific acts as a much more efficient retention system than previously assumed for certain types of floating material. The currents of the subtropical gyre not only concentrate existing plastic, but can retain and recirculate objects for decades before they reach the coasts or sink. This dynamic has direct implications for understanding how pollutants, invasive organisms, and nutrients are distributed in the North Pacific basin. The Lemuria hypothesis emerged in the 19th century as an attempt to solve a specific zoogeographical problem: the presence of lemurs, primates native to Madagascar, in India and in some parts of Southeast Asia, without there being a known land route that would explain their dispersal. The British geologist Philip Sclater proposed in 1864 the existence of a submerged continent in the Indian Ocean that would have acted as a land bridge, and named it Lemuria in honor of the lemurs. Sclater's hypothesis was scientifically serious for its time, but became obsolete with the development of the theory of plate tectonics, which explained the distribution of lemurs through continental drift. However, the idea of Lemuria was appropriated by theosophy and by various esoteric currents, especially by Helena Blavatsky, who turned it into the home of a supposed ancestral race of humanity. This cultural appropriation detached the concept from its geological origin and introduced it into the realm of the mythical. What is scientifically solid is that sea level during the glacial periods of the Pleistocene was between 120 and 130 meters lower than today. This means that vast areas of the Pacific continental shelves were exposed and inhabited for prolonged periods. Sunderland, the continental shelf of Southeast Asia, was a continent the size of Western Europe during the last glacial maximum, approximately 20,000 years ago, uniting what are now the islands of Borneo, Java, Sumatra, and the Malay Peninsula into a single landmass. Distinct from Lemuria, the hypothesis of the continent, Mu, was popularized in the early 20th century by the writer and amateur researcher James Churchward, who claimed in a series of books published between 1926 and 1931 to have deciphered clay tablets in India that described a submerged continent in the Pacific, the cradle of all civilizations. Unlike Lemuria, Mu had no initial geological basis. It was a narrative construct supported by sources that no other researcher could verify. However, Churchward's coincidence with certain real geological data has fueled its popular longevity. The Pacific indeed hosts submerged continental shelves, seamounts that were once islands, and chains of atolls that indicate gradual land subsidence. None of this supports a suddenly submerged continent, but rather slow geological processes of subsidence and sea level change. The difference between what Churchward described and what geology documents is fundamental. Where he postulated a recent catastrophe, science shows gradual changes over thousands or millions of years. In 2017, a team of New Zealand and Australian geologists published in the journal GSA Today the formal description of Zealandia, a submerged continent of 4.9 million square kilometers that constitutes approximately 94% of its mass beneath the waters of the southwestern Pacific. Only New Zealand and New Caledonia rise above the water as the emergent fragments of this continent, which separated from the supercontinent Gondwana between 60 and 85 million years ago and gradually subsided as its crust thinned due to tectonic stretching. The existence of Zealandia was not a geological secret, but its formalization as a continent, the eighth recognized, required verification that it met all the criteria that define a continent: elevation above the surrounding ocean floor, distinct continental geology, crust of continental thickness, and clear geographic delimitation. Oceanographic campaigns carried out between 2017 and 2023, including drilling of the ocean floor, BMISGERIT, the International Ocean Discovery Program, have confirmed the geological history of Zealandia and have revealed evidence that part of its surface was emergent in relatively recent periods, between 25 and 30 million years ago, forming archipelagos that could have served as corridors for fauna dispersal between Australia and the Pacific. In 1986, diver Kihachiro Aratake discovered off the coast of the Japanese island of Yonaguni, at the southern end of the Ryukyu Islands, a large underwater structure that presented notably regular geometric shapes. The main structure, known as the Yonaguni Monument, extends for about 100 meters and rises about 25 meters from the seabed. Its most striking features are the staircases, right angles, horizontal terraces, and the perfectly cut rock blocks that compose it. The scientific debate that opened following its discovery remains active. Geologist Masaaki Kimura from the University of the Ryukyus argued that it is an artificial construction, or at least modified by human beings between 2,000 and 10,000 years ago. The more skeptical position holds that the structure can be explained entirely by natural geological processes. The rock of the monument is sandstone and mudstone, materials that tend to fracture at angles close to 90 degrees due to the orientation of their bedding planes. What is not in dispute is that the area was exposed during the last glacial period and that it could have been inhabited by human populations. More recent archaeological approaches tend toward an intermediate position. The formation is mainly natural, but may have been used, modified on a small scale, or venerated by prehistoric populations. In the North Pacific, bathymetric data from the Beringia continental shelf, the zone that connected Asia with America during glacial periods, have revealed landscapes of river valleys, plains, and what appear to be areas of ancient vegetation at depths between 50 and 100 meters. Sediment studies in those areas have recovered fragments of wood and organic remains that corroborate the existence of terrestrial ecosystems in places currently covered by the Bering Sea. Underwater archaeology has begun to address this problem in the Mediterranean and along some European coasts. But in the Pacific, the scale of the potential territory to be explored makes the undertaking a challenge for the coming decades. The East Pacific Rise is one of the most active seafloor spreading systems in the world. Unlike the Mid-Atlantic Ridge, which expands at a rate of between 2 and 3 centimeters per year, the East Pacific Rise separates at a speed of between 15 and 17 centimeters annually in some of its segments, making it one of the fastest geological processes on the Earth's surface. This expansion is responsible for the Pacific widening, while the Atlantic remains comparatively narrower. Along the ridge, magma from the mantle continuously rises to fill the space left by the tectonic plates as they separate, generating new oceanic crust and giving rise to one of the most extraordinary ecosystems on the planet, hydrothermal vents, or black smokers. First discovered in 1977 by an expedition from the Scripps Institution of Oceanography aboard the submersible Alvin on the Galapagos Rift, hydrothermal vents revolutionized the understanding of the limits of life. Black smokers are structures formed by the deposition of minerals when cold seawater infiltrates the oceanic crust, heats upon contact with molten rock, reaches temperatures of up to 400 degrees Celsius and emerges under high pressure through fractures in the ocean floor. Upon contact with the surrounding cold water, the dissolved minerals precipitate and form the characteristic tubular structures, black due to their content of iron and manganese sulfides. What made this discovery a scientific milestone was the verification that an entire ecosystem thrived around these chimneys, based not on photosynthesis, but on chemosynthesis. Bacteria and archaea that obtain energy from the oxidation of sulfur compounds form the base of food chains that include tube worms up to 2 meters in length, white-furred yeti crabs, chemosynthetic mussels, and specialized predatory fish, all of this in complete absence of sunlight. The discovery of chemosynthesis as the basis of a complex ecosystem radically altered the criteria used to evaluate the habitability of other planets. If life can thrive without sunlight on the floor of the Pacific, it may also exist in the oceans beneath the ice of Jupiter's moon, Europa, or Saturn's moon, Enceladus, where plumes of water vapor and evidence of hydrothermal activity have been detected. The Pacific hosts the richest concentrations of hydrothermal vents of all the oceans, with active fields documented along the entire East Pacific Rise, in the Lau Basin, on the Juan de Fuca Ridge, off the northwestern American coast, and in numerous volcanic arc zones of the western Pacific. Each new field discovered has revealed previously unknown species. Loihi is an active submarine volcano located about 35 kilometers southeast of the Big Island of Hawaii, under approximately 975 meters of water. It is the youngest volcano in the Hawaiian archipelago and, geologically, the one with the most future. At some point in the next 10 to 100,000 years, its continuous eruptions will raise its summit above sea level and create a new Hawaiian island. The activity of Loihi is not theoretical. In July and August of 1996, the largest series of earthquakes related to this volcano ever documented was recorded, with more than 4,000 seismic events in a few weeks. Submersibles that descended to its summit found that part of its caldera had collapsed, forming a new crater 1 kilometer in diameter. Gas and lava emissions had created entirely new hydrothermal vent fields. The process that produces Loihi is the same that has generated all the Hawaiian Islands, the movement of the Pacific Plate over a fixed hotspot in the mantle. The Hawaiian chain, 2,400 kilometers long, is the geological record of that journey. From Loihi, which has just begun, to the submerged mountains of the Emperor Chain to the northwest, whose summits are now 3 or 4 kilometers below water, and were islands between 70 and 80 million years ago. The Pacific contains the most extensive oxygen minimum zones on the planet, bands of the water column at depths between 200 and 1,000 meters, where the concentration of dissolved oxygen drops to levels lethal for most organisms. These zones form when the biological demand for oxygen to decompose organic matter raining down from the surface exceeds the rate of replenishment from upper layers. In the eastern tropical Pacific, the oxygen minimum zone covers millions of square kilometers at mid-depths, compressing marine ecosystems toward the surface or the bottom. Fish, squid, and other organisms that depend on oxygen are forced to concentrate in thinner surface layers than would be their natural distribution, creating unusually high densities of life in those zones and biological deserts in the mid-levels of the water column. Measurements taken in recent decades indicate that these zones are expanding. Ocean warming reduces the solubility of oxygen in water and weakens the vertical circulation that normally carries oxygenated water to depth. Studies published in journals such as Science and Nature document a vertical and horizontal expansion of the Pacific oxygen minimum zones since at least the 1970s. One of the less visible but more significant consequences is the alteration of the oceanic nitrogen cycle. In the absence of oxygen, certain bacterial groups use dissolved nitrate as an alternative oxidant, releasing gaseous nitrogen and depleting the chemical fertility of the ocean. El Niño is, strictly speaking, an oscillation of the coupled ocean-atmosphere system in the equatorial Pacific, known as ENSO, for its English acronym El Niño Southern Oscillation. In its warm phases, the weakening of the trade winds allows warm water accumulated in the western Pacific to move eastward, altering sea surface temperature over thousands of kilometers and reorganizing precipitation and temperature patterns across the entire planet. The El Niño event from 1997 to 1998 was the most intense recorded up to that time, with sea surface temperature anomalies in the equatorial Pacific of up to 5 degrees above normal. Its effects included devastating floods in Peru and Ecuador, extreme droughts in Australia and Indonesia, massive coral reef bleaching across the tropical Pacific, and a profound disruption of fisheries from California to Chile. The 2015 to 2016 event equaled or surpassed that of 1,997 inches some metrics. The opposite phase of the ENSO cycle, known as La Niña, produces symmetrical effects: intensification of the trade winds, accumulation of warm water in the western Pacific, cooling of the central and eastern Pacific, and increased rainfall in Australia, Indonesia, and Southeast Asia. Years of strong La Niña are associated with droughts in western North America, floods in eastern Australia, and more active cyclone seasons in the western Pacific. The interaction between long-term climate change and the natural variability of ENSO is one of the most important open problems in current climate science. The Pacific also hosts a global-scale oceanic anomaly that complements ENSO and operates on much slower cycles. The Pacific Decadal Oscillation, PDO, for its English acronym, which alternates between warm and cold phases with a periodicity of between 20 and 30 years. During warm phases of the PDO, the northeastern Pacific experiences elevated surface temperatures, and salmon fisheries along the northwestern American coast tend to be productive. During cold phases, the situation reverses. The PDO interacts with ENSO such that when both are in a warm phase simultaneously, their effects are amplified. When they are in opposite phases, they dampen each other. This interaction between cycles of different temporal scales makes Pacific climate prediction one of the most complex endeavors in modern oceanography. Long before precision instruments and satellite positioning systems existed, Polynesian navigators colonized the Pacific Ocean across an expanse of more than 10,000 kilometers in all directions from their origin islands in the western Pacific. Between 1000 BC and AD 1200, they reached and settled Hawaii, Easter Island, New Zealand, and hundreds of intermediate archipelagos aboard sailing and rowing catamarans, using navigation by stars, currents, birds, and clouds. The Polynesian Triangle, defined by the vertices of Hawaii, Easter Island, and New Zealand, covers approximately 28 million square kilometers of ocean, more than the entire land surface of Asia. The magnitude of that navigational enterprise has no parallel in any other prehistoric culture in the world. For decades, Western researchers refused to accept that peoples without compasses or astronomical instruments could have crossed such distances with intention and precision, preferring hypotheses of accidental drift. Research conducted since the 1970s with replicas of Polynesian vessels, especially the work of the Polynesian Voyaging Society with Hokulea, a double-hulled catamaran reconstructed using traditional techniques, demonstrated that intentional navigation was entirely possible. Polynesian navigators used the position of the stars and their height above the horizon as a reference for latitude, observed wave patterns refracted by islands to detect land at distances of hundreds of kilometers, followed the migration routes of specific birds, and read the color and temperature of the water as indicators of currents and nearby landmasses. Among the mysteries surrounding Polynesian colonization is the existence of oral traditions that mention submerged islands and territories. Some of these references have proven to have verifiable geological correlates. The island of Rurutu, in French Polynesia, has in its adjacent submarine seabed a volcanic platform indicating a much greater land extension in the past. The analysis of marine sediments around several atolls in the Central Pacific shows deposition levels, suggesting the presence of emergent coastlines during times of lower sea levels. The most surprising case is that of the Marshall Islands in the Central Pacific, whose oral traditions describe in detail the progressive flooding of low-lying lands over several generations. Geological and archaeological studies carried out in the 1990s on Marshall Atolls found evidence of human settlements in areas currently submerged under between 1 and 3 meters of water, consistent with the rate of sea level rise in recent centuries and the gradual sinking of coral atolls due to subsidence. Easter Island, Rapa Nui, in the language of its inhabitants, is one of the most remote inhabited territories on the planet, 3,700 kilometers from the coast of Chile and 2,000 from the nearest inhabited island, Pitcairn. Its 887 moai, monolithic statues carved in volcanic tuff with weights ranging from 3 to 80 tons, have generated debates that extend far beyond the archaeological field. What is often overlooked in discussions about the moai is the island's underwater context. The ocean floor around Rapa Nui presents significant peculiarities. The island rests on the crest of the southeastern Pacific volcanic ridge, and its submarine platforms preserve evidence that the island was considerably more extensive in the past. Bathymetric analyses carried out in 2021 by the expedition of the Chilean Antarctic Institute revealed submarine terraces at depths between 50 and 100 meters corresponding to ancient coastlines, indicating that Rapa Nui may have had double its current surface area between 8,000 and 12,000 years ago. The question that arises is what relationship that greater territorial extent may have had with the civilization that built the moai. If farmland and fishing resources were more abundant on a larger island, the ecological and demographic collapse, archaeologically documented for the 16th and 17th centuries, may have begun much earlier than the material records on land suggest, accelerated not only by deforestation but also by the progressive loss of productive coastal territory as sea levels rose during the Holocene. This hypothesis, still in a preliminary research phase, connects submarine geology with the archaeology and social history of one of the most studied and least understood civilizations in the Pacific. Between 2018 and 2019, explorer Victor Vescovo completed the 5 Deeps expedition, whose objective was to descend to the deepest point of each of the 5 oceans. In the Pacific, the destination was the Challenger Deep in the Mariana Trench. Vescovo reached the bottom in May 2019 aboard the submersible DSV limiting factor and achieved a depth of 10,928 meters, which at that time constituted the deepest human descent in history. What he found at the bottom, in addition to the record depth, included plastic bags and candy wrappers, once again demonstrating that human pollution precedes human exploration in the most remote places on the planet. He also collected biological samples that are being analyzed by scientific teams from various universities and discovered new species of crustaceans and sedimentary organisms that are still being classified. The 5 Deeps expedition also produced high-resolution bathymetric mapping of the 5 deepest points on the planet, with data that have significantly refined models of the ocean floor in those areas. In the Mariana Trench, the multi-beam sonar of the support vessel Pressure Drop detected at least 4 large geological structures that had not appeared on any previous chart, 2 chains of volcanic hills, a fracture zone with a drop of more than 800 meters, and what appear to be relatively recent lava deposits on the western flank of the trench, suggesting volcanic activity in the vicinity of the subduction zone with a higher frequency than previously estimated. In 2023, the Ocean Census was formally launched, a global initiative bringing together more than 70 scientific institutions worldwide, with the objective of documenting 1 million unknown marine species in 10 years. The most conservative estimates suggest that between 60 and 80% of marine species remain scientifically undescribed. In the case of the deep Pacific zones, the proportion of the unknown is even greater. Autonomous underwater exploration vehicles, ROVs and AUVs, have transformed sampling capabilities at depths that previously required costly and operationally limited crude submersibles. eDNA techniques, environmental DNA analysis, allow the detection of organisms in water samples without the need to capture or even see the organism. A liter of deep Pacific water contains DNA fragments from dozens of species, including some that have never been directly observed. One of the least explored dimensions of the deep Pacific is bioluminescence on a massive scale. Current estimates indicate that approximately 76% of deep Pacific marine organisms are capable of producing light, turning the dark ocean into a space dotted with luminous signals of communication, hunting, and defense. Low-light camera recordings from recent expeditions have documented flashes, pulsating patterns, and clouds of diffuse light corresponding to communities of bioluminescent organisms whose vertical and horizontal distribution in the Pacific water column is only beginning to be mapped. In 2020, marine biologist Stephen Haddock published an analysis of ROV images from the North Pacific that identified patterns of synchronized bioluminescence in jellyfish communities at depths between 200 and 600 meters, a phenomenon whose biological function remains under study. The Clarion-Clipperton Zone, a region of the Central Pacific covering more than 4 million square kilometers located between Mexico and Hawaii, hosts the largest known deposits of polymetallic nodules in the world. These nodules, concretions of manganese, cobalt, nickel, and copper that form around organic remains over millions of years, cover the seafloor in some areas like a pavement and contain essential metals for the global energy transition. Expeditions in recent years have revealed that the Clarion-Clipperton Zone hosts extraordinary biodiversity, with more than 5,000 species, most completely new to science, living among the nodules and in the surrounding sediments. The International Seabed Authority has received dozens of exploration applications for this area, and the debate over economic benefits versus ecological risks of deep-sea mining is one of the most intense in current international environmental policy. What has become clear is that the floor of the Clarion-Clipperton Zone is not the sterile mineral desert once assumed, but rather a highly diverse ecosystem with slow recovery that would take millions of years to regenerate if damaged. A particularly striking aspect of the polymetallic nodules in the Clarion-Clipperton Zone is the time required for their formation. These nodules grow at a rate of between 1 and 10 millimeters per million years, making them some of the slowest growing structures on the planet. A nodule 10 centimeters in diameter is therefore between 10 and 100 million years old. This extreme longevity means that the ecosystems that depend on the nodules as substrate, including sponges, cold water corals, and specialized microbial communities, have developed on a stable base over periods of time that exceed the entire history of primates. Small-scale mining experiments conducted in the 1970s and 1980s in the area have shown that disturbed biological communities show no signs of significant recovery even 40 years later. The Pacific is, among other things, the largest archive on the planet. Its sediments preserve climatic records that date back hundreds of millions of years. Its water layers retain isotopes and dissolved compounds that have been in circulation for more than 1,000 years. Its seabeds store the remains of civilizations, fleets, and ecosystems that no longer exist. Its sounds travel thousands of kilometers through the SOFAR channel, carrying information about earthquakes, eruptions, and biological processes occurring in the most remote parts of the basin. Every expedition that descends into its depths returns with data that reconfigure existing models. The Mariana Trench proves more complex than early soundings suggested. The Clarion-Clipperton Zone hosts more life than anyone suspected. Mysterious sounds have geological and biological explanations that awaited the appropriate instruments to be revealed. Submerged continents are real lands that were once inhabited and now preserve the vestiges of that occupation beneath the water. Shipwrecks from the Second World War become reefs. Patches of warm water reorganize entire ecosystems. Submarine volcanoes build islands while the planet watches. Chemosynthetic bacteria thrive 11 kilometers deep, without light, without surface heat, nourished by sulfur escaping from the Earth. And at some point in the water column, between 100 and 1,000 meters deep, creatures continue to travel whose dimensions have not yet been measured, evading nets and sonar with the ease of having inhabited this space for millions of years before anyone existed to try to find them. Sedimentary records of the Pacific, extracted through drilling within the framework of international programs such as the Ocean Drilling Program and its successor, the International Ocean Discovery Program, have provided some of the most detailed paleoclimatic reconstructions that exist. Sediment columns, recovered from Pacific drillings, can be 100 meters long and represent 50 million years of climatic history, with a resolution of a few centuries per centimeter of sediment. Within those columns are recorded the major events of the ocean's past: the Paleocene, Eocene, thermal maximum 56 million years ago, when the average ocean temperature was more than 10 degrees higher than today, the formation of the first permanent ice sheet in Antarctica 34 million years ago, which transformed the global ocean circulation system, and the glacial cycles of the Pleistocene, with their temperature oscillations of 4 to 5 degrees that submerged and exposed the Pacific coastal continents in a rhythm repeated dozens of times over the last 2 million years. Each of those oscillations left its chemical signature in the sediments, and each of them radically transformed the distribution of life in the Pacific, extinguishing some species, expanding others, and opening corridors or raising barriers between populations that had previously been connected. The Pacific has not finished revealing what it holds.